Jai Hind to everyone. My name is MILI SRIVASTAVA and today I am going to discuss about virtualization. What is virtualization and why it is important in cloud computing? Virtualization plays very important role in cloud computing. With the help of virtualization, we can access our hardware with the help of hypervisor. We can divide that hardware into different virtual machines. So, this is the diagram of virtualization. In this, there is apps, binary libraries, guest operating system, and this is virtualization, server hardware, host operating system, and hypervisor. Hypervisor is a software by which, with the help of hypervisor, we can convert our hardware into virtual machine. Next, virtualization. What is virtualization and why it is needed? Virtualization is a technique of how to separate a service from the underlying physical delivery of that service. It is the process of creating a virtual version of something like computer hardware. It was initially developed during the mainframe era. This is traditional architecture and this is virtual architecture. With the help of virtualization, there is no any wastage of our hardware. In virtualization, it involves using a specialized software to create a virtual or software created version of a computing resources rather than the actual version of the same resource. With the help of virtualization, multiple operating systems and applications can run on same machines and is same hardware at the same time, increasing the utilization and flexibility of hardware. When we create virtual machines with the help of hypervisor, all the virtual machines are independent to each other. They have different operating systems. One of the most cost-effective hardware reducing and energy saving techniques used by cloud providers is virtualization. Virtualization allows sharing a single physical instance of a resource or an application among multiple customers and organization at one time. It does by assigning a logical name to a physical storage and providing a pointer to that physical resource demand. The term virtualization is often synonym with hardware virtualization, which plays a fundamental role in efficiently delivering infrastructure as a service solution for cloud computing. Basically, we use virtualization in one of the service provided by cloud computing, this is infrastructure as a service. Virtualization technologies provide a virtual environment for not only executing applications but also for storage, memory and networking. There are some benefits of virtualization. As I already said, virtualization plays very important and useful role in cloud computing. With the help of virtualization, we can create many virtual machines with our hardware that are very useful for memory management and hardware utilization also. Benefits of virtualization: more flexible and efficient allocation of resources, enhanced development productivity. It lowers the cost of IT infrastructure, remote access and rapid scalability, high availability and disaster recovery, pay per use of the IT infrastructure on demand, enables running multiple operating systems. Key cloud security benefits with virtualization. Virtualization technology is very much flexible. Organizations have the flexibility to share systems without essentially having to share critical information or data across the system. Data protection. In virtualization, our data is also protected. They can prevent loss or damage because there are another clouds to provide data storage. So, we are assuming that our data is totally safe. They can prevent loss or damage. If one cloud is damaged, then our data also stored in another cloud. In cases where the system is compromised owing the malicious activities. Security against attacks. They have the ability to reduce the risk of multiple attacks in case of an exposure by methodological isolating applications and virtual machines. Key cloud security benefits with virtualization. Cost effective. It improves the physical security of organizations by reducing hardware requirements, thereby leading to fewer data centers. Better access control. A higher level of access control is offered to system and network administrators, which separates responsibilities and improves the system's efficiency. There is a diagram of benefits of virtualization: machine data transfer, flexibility, future protection, easy recovery, cost efficiency, streamlined optimization and processing. So there are types of virtualization. Basically there are desktop virtualization, application virtualization, network virtualization and storage virtualization. So this is the four types of virtualization: application, network, desktop and storage virtualization. Application virtualization basically used for developers in the application platforms. Application virtualization: when the virtual machine hardware and virtual machine manager is directly installed on the host system, this is called application virtualization. It is basically used by developers. It helps a user to have a remote access of an application from a server. The server stores all personal information and other characteristics of the application, but can still run on a local workstation through internet. Example of this would be a user who needs to run two different versions of the same software. Technologies that use application virtualization are hosted applications and packaged applications. Network virtualization. What is network virtualization? The ability to run multiple virtual networks which each has a separate control and data plan. It coexists together on top of one physical network. It can be managed by individual parties that potentially confidential to each other. Network virtualization provides a facility to create and provision virtual networks, logical switches, routers, firewalls, load balancer, virtual private network, and workload security within days or even in weeks. What is desktop virtualization? When virtual machine software and virtual machine manager is directly installed on the operating system, this is called desktop virtualization. Desktop virtualization allows the user's operating system to be remotely stored on a server in the data center. It allows the user to access their desktop virtually from any location via different machines. Users who want specific operating systems other than Windows Server will need to have a virtual desktop. Main benefits of desktop virtualization are user mobility, portability, easy management of software installation, updates and patches. Next is storage virtualization. Storage virtualization basically used for data storage. Storage virtualization is an array, just like array, of servers that are managed by virtual storage system. The servers are not aware of exactly where their data is stored and instead function more like worker bees in a hive. It makes managing storage from multiple sources to be managed and utilized as a single repository. Storage virtualization software maintains smooth operations, consistent performance, and a continuous suite of advanced functions despite changes, breakdown, and differences in the underlying equipment. Implementation levels of virtualizations. There are some implementation levels of virtualization which are also very important in virtualization. Virtualization is a computer architecture technology by which multiple virtual machines are multiplexed in the same hardware machine. The purpose of a virtual machine is to enhance resource sharing by many users and improve computer performance in terms of resource utilization and application flexibility. The idea is to separate the hardware from the software to yield better system efficiency. A traditional computer runs with a host operating system specially tailored for its hardware architecture as shown in this diagram. This is traditional computer and this is after virtualization. This is our hardware running the host operating system, and with the help of hypervisor, which is software, and hypervisor converts our hardware host system into virtual machines. This is application guest operating system. Basically these are the virtual machines. Virtualization basically used for better utilization of hardware. Implementation levels of virtualization. After virtualization, different user applications managed by their own operating systems, guest operating systems, can run on the same hardware independent of the host operating system. This is often done by adding additional software called a virtualization layer as shown in this diagram. Virtualization can be implemented various operation levels as given below. First is instruction set architecture, ISA level. Second, hardware level. Third, operating system level. Next, library support level and application level. Basically implementation, there are some steps of implementation in virtualization. This is the diagram of virtualization implemented levels. This is application level, this is library level, operating system level, hardware abstraction layer, and this is instruction set architecture. Virtualization can be implemented at various operational levels. Instruction set architecture level, for example, MIPS binary code can run on an x86 based host machine with the help of ISA emulation. With this approach, it is possible to run a large amount of legacy binary code written for various processors on any given new hardware host machine. Instruction set emulation leads to virtual ISAs created on any hardware machine. One source instruction may require tens or hundreds of native target instructions to perform its function. This approach translates basic blocks of dynamic source instructions to target instructions. Instruction set emulation requires binary translation and optimization. Hardware abstraction level. It is performed right on top of the bare hardware and generates a virtual hardware environment for a virtual machine. On the other hand, the process manages the underlying hardware through virtualization. The idea is to virtualize a computer's resources such as its processors, memory and input-output devices so as hardware utilization rate by multiple users concurrently may be upgraded. Operating system level. In operating system level, virtualization creates isolated containers or a single physical server and the operating system instances to utilize the hardware and software in data centers. The containers behave like real servers. Operating system level virtualization is commonly used in creating virtual hosting environment to allocate hardware resources among a large number of mutually distrusting users. Library support levels. In library support levels, virtualization with library interfaces is possible by controlling the communication link between application and the rest of the system through API host. The software tool Wine has implemented this approach to support Windows application on top of Unix host. Another example is the CUDA, which allows applications executing within virtual machines to leverage GPU hardware accelerations. Next is user application level. In user application level, on our traditional operating system, an application often runs as a process. Therefore, application level virtualization is also known as process level virtualization. The most popular approach is to deploy high level language virtual machines. In this scenario, the virtualization layer exports an abstraction of a virtual machine that can run program written and compiled to a particular abstract machine definition. Any program written in the high level language and compiler for this virtual machine will be able to run on it. The Microsoft.NET CLR and Java virtual machine are two good examples of this data of virtual machine. Other forms of application level virtualization are known as application isolation, application sandboxing, or application streaming. The process involves wrapping the application in a layer that is isolated from the host operating system, and other applications result in the application that is much easier to distribute and remove from user workstations. How virtualization supports at the operating system level. It is slow to initialize a hardware level. First of all, whenever virtual machine software and virtual machine manager directly installed on the operating system, that virtualization is called operating system level virtualization. It is slow to initialize hardware level virtual machine because each virtual machine creates its own image from scratch, or storage of such images are also slow. Operating system level virtualization provides a feasible solution for these hardware level virtualization issues. Operating system virtualization inserts a virtualization layer inside an operating system to partition a machine's physical resources. It enables multiple isolated virtual machines within a single operating system kernel. This kind of virtual machine is often called a virtual execution environment. The virtual execution environment has its own set of processes, file system, user accounts, network interfaces with IP address, routing tables, firewall rules, and other personal settings. What are the advantages of operating system level? Virtual machines at the operating system level have minimal startup, shutdown cost, low resource requirements, and high scalability. It is possible for a virtual machine and its host environment to synchronize state change when it is necessary. This is virtualization structure and tools and mechanisms. Before virtualization, the operating system manages the hardware. After virtualization, a virtualization layer is inserted between the hardware and the operating system. In such case, the virtualization layer is responsible for converting portions of the real hardware into virtual hardware. Depending on the position of the virtualization layer, there are several classes of virtual machines architecture, namely hypervisor architecture, para-virtualization, and host-based virtualization. Hypervisor and Xen architecture. Depending on the functionality, a hypervisor can assume a microkernel architecture or a monolithic hypervisor architecture. A microkernel hypervisor includes only the basic and unchanging functions such as physical memory, management, and processor scheduling. The device drivers and other changeable components are outside the hypervisor. A monolithic hypervisor implements all the aforementioned functions, including those of the device drivers. Therefore, the size of the hypervisor code of a microkernel hypervisor is smaller than that of monolithic hypervisor. Xen architecture. Xen is open source hypervisor program developed by Cambridge University. Xen is a microkernel hypervisor which separates the policy from the mechanism. It implements all the mechanisms, leaving the policy to be handled by domain O. As shown in the figure, Xen does not include any device drivers natively. It just provides some mechanism by which a guest operating system can have direct access to the physical devices. Like other virtualization systems, many guest operating systems can run on top of the hypervisor. The guest operating system, privileged guest operating system, which has control ability, is called domain, and the other are called domain U. It is first loaded when Xen boots without any file system drivers being available. Domain O is designed to access hardware directly and manages devices. This is the diagram. This is Xen architecture. This is hardware device. There is hypervisor of Xen, and these are the virtual machines which are created by this hardware device for better utilization. Hardware for better hardware utilization. Binary transmission with full virtualization. Depending on implementation technologies, hardware virtualization can be classified into two categories. The first one is full virtualization and the second is host-based virtualization. So, what is full virtualization? With full virtualization, non-critical instructions run on the hardware directly, while critical instructions are discovered and placed with traps into the virtual machine manager to be emulated by software. Both the hypervisor and virtual machine manager approaches are considered full virtualization. Non-critical instructions do not control hardware or threaten the security of the system, but critical instructions do. Therefore, running non-critical instructions on hardware not only can promote efficiency but also can ensure system security. What is host-based virtualization? In host-based virtualization, an alternative virtual machine architecture is to install a virtualization layer on top of the host operating system. This host operating system is still responsible for managing the hardware. The guest operating systems are installed and run on top of the virtualization layer. Dedicated applications may run on the virtual machines. Certainly, some other applications can also run with the host operating system directly. The host-based architecture has some distinct advantages as enumerated next. First, the user can install the virtual machine architecture without modifying the host operating system. Second, the host-based approach appeals to many host machines configurations. Next, para-virtualization. Para-virtualization, what is para-virtualization? It needs to modify the guest operating system. A para-virtualization virtual machine provides special APIs requiring substantial operating system modifications in user applications. Performance degradation is a critical issue of virtualized system. The guest operating system are para-virtualized. They are assigned by an intelligent compiler to replace the non-virtualizable operating system instructions by hypercalls. The traditional x86 processors offers the instruction execution rings 0, 1, 2 and 3. The lower ring number, the higher the privilege of instruction being executed. The operating system is responsible for managing the hardware and the privileged instructions to execute at ring O, while user level applications run at ring 3. What is para-virtualization? What are the problems which are observed in para-virtualization? Compatibility, portability, and the cost is very high comparison of other virtualization. Virtualization of CPU, memory, and input-output devices. To support virtualization, processors such as x86 employ a special running mode and instructions known as hardware-assisted virtualization. What are hardware support for virtualization? Modern operating systems and processors permit multiple processes to run simultaneously. If there is no protection mechanism in processor, all instructions from different processes will access the hardware directly and cause a system crash. Therefore, all processors have at least two modes, user mode and supervisor mode, to ensure controlled access of critical hardware. Instructions running in supervisor mode are called privileged instructions. This software suite allows user to set up multiple x86 and x86-64 virtual computers and to use one or more of these virtual machines simultaneously with the host operating system. The virtual machine workstation assume the host-based virtualization. This is the diagram of hardware support for virtualization, how hardware supports in virtualization. Next is CPU virtualization. Behavior sensitive instructions have different behavior depending on the configuration of resources, including the load and store operations over the virtual memory. A CPU architecture is virtualizable if it supports the ability to run the virtual machine's privileged and unprivileged instructions in the CPU's user mode while the virtual machines runs in supervisor's mode. When the privileged instructions, including control and behavior sensitive instructions of a virtual machine, are executed, they are trapped in the virtual machine. In the case, virtual machine manager acts as a unified mediator of hardware access from different virtual machines to guarantee the correctness and stability of the whole system. RISC CPU architecture can be naturally virtualized because all control and behavior sensitive instructions are privileged instructions. On the contrary, x86 CPU architectures are not primarily designed to support virtualization. When these instructions execute in virtualization, they cannot be trapped in virtual machines. Hardware assisted CPU virtualization. In hardware assisted CPU virtualization, this technique attempts to simplify virtualization because full or para virtualization is complicated. Intel and AMD add an additional mode called privileged mode level. Some people call it ring 1. Two x86 processors, therefore operating systems can still run at ring 0 and the hypervisor can run at ring 1. All the privileged and sensitive instructions are trapped in the hypervisor automatically. This technique removes the difficulty of implementing binary translation of full virtualization. It is also the operating system run in virtual machines without modification. This is hardware assisted CPU virtualization explanation with the help of diagram. You can see this is ring 0, this is ring 3, And virtual machine root mode, this is virtual machine root mode. How it works: in this memory and input output virtualization works. This is virtual machine entry, exit, configuration. We can divided a particular part for virtual machine configuration that controls virtual machines also. This is virtual machine control structure. Direct input output virtualization. Input output virtualization is technology that uses software to abstract upper layer protocols from physical connections or physical transports. This technique takes a single physical component and presents it to devices as multiple components. This is memory virtualization. Just like array memory, we can also happen there some virtual machines processes, and we can also locate that with the help of indexing. This is memory virtualization. This is physical memory part, and machine memory part we can access that with the help of this indexes. We can access that memory part from anywhere. Memory virtualization, that means a two-stage mapping process should be maintained by the guest operating system and virtual machine manager respectively. Virtual memory to physical memory and physical memory to machine memory. The guest operating system continues to control the mapping of virtual addresses to the physical memory addresses of virtual machines, but the guest operating system cannot directly access the actual machine's memory. The virtual machine memory is responsible for mapping the guest physical memory, the actual machine memory. Virtual hierarchy. A virtual hierarchy is a cache hierarchy that can adapt to fit the workload or mix of workloads. The hierarchy's first level locates data blocks close to the cores needing them for faster access, establishes a shared cache domain, and establishes a point of coherence for faster communication. The first level can also provide isolation between independent workloads. A miss at the L1 cache can invoke the L2 access. This is virtual hierarchy, memory hierarchy. We can easily access by this hierarchy system any data from anywhere. Virtual support and disaster recovery. This is also very important, one of the very important part of virtualization. There are basically 4 ways virtualization helps with disaster recovery and are recover to any hardware, backup and restore full images, run other workloads on standby hardware, easily copy system data to recover site. This is basically difference between virtualization and cloud. The first is definition. Virtualization is technology based and the cloud is methodology based. Purpose: create multiple simulated environments from one physical hardware system, and in case of cloud, pool and automate virtual resources for on demand use. Uses delivery packaged resources to specific users for a specific purpose, and in case of cloud, deliver variable resources to groups of users for a variety of purposes. Configuration: in case of virtualization, this is image based or virtual, and in case of cloud, this is template based. Lifespan: years, long time in case of virtualization, but in case of cloud, this is hours or months, is short term. As we can see, this is scalable, very much scalable. Cloud computing. Cloud cost: high capital expenditures, low operating expenses, but in case of cloud, private cloud, high CAPEX, low OPEX, public cloud, low CAPEX, high OPEX, high capital expenditures. Scalability: scale up. In case of virtualization, we can scale up, and in case of cloud, we can scale up or scale down anytime, anywhere. Workload: stateful and stateless in case of cloud computing. Tenancy: in virtualization, there is a single tenancy but in case of cloud computing there is multiple tenancy. Thank you.